let's clarify delta G naught. Before I start delta G naught, let's go back to K again. Sulfuric acid, is that a strong or weak acid? And it's one of the acids you have to memorize, the strong acid. But just from this K value, I know it's a strong acid because K is very large. Now I want to emphasize what K means. K can tell us me two things. First thing is we are at equilibrium, right? And the second thing K tells me is I have more product than reactant. Therefore, I know sulfuric acid is a strong acid because I make a lot of product. Okay? So just to reiterate, what K tells me is two things. I'm at equilibrium, and two is it shows me how much product to reactant ratio I have. So if K is large, more product than reactant. If K is small, reactants greater than product. Or more specifically, if K is greater than 1, and then K small is K is less than 1. Okay? Now, how does this relate to delta G naught is what's interesting is exactly the same thing. And let me show you. I have the same reaction here, okay? And here this time, let's just say K equals 5. And once again, just to repeat myself, K tells me two things. A, we are in equilibrium. And in this reaction, I have more product than reactant. Do you guys remember this equation, negative G naught RT ln K? What happens if I plug in this number? What I get is delta G naught is equal to negative 2.3. Okay? When you see this, it looks kind of weird, right? But hang with me. When I said K equals 5, you knew automatically I had more products than reactant, and we were at equilibrium. Likewise, if delta G naught is negative, that tells me two things. A, we are in equilibrium, and two, I have more product than reactant. So to clarify, K equals 5 is exactly the same thing as delta G naught equals negative 2.3. Can you guys see that? Because I know there's a lot of confusion between delta G and delta G naught, but moving forward, delta G naught is the same thing as K. And that's all that means. So let's just do one quick question, or a couple of questions. What is delta G naught when K equals 5? Now, do you see the wording how I asked this? I am showing you that delta G naught and K is telling you the same story in two different ways. And so if I plug in a number, right? Delta G naught equals negative RT ln K. And for our example, let's just say RT is equal to 2. Okay? So delta G naught equals negative 2 times 5, which is 2.3. Okay? And so here, K says I have more product reactant, and since delta G naught is negative, it tells me I have more product reactant. And likewise, you should also feel comfortable going reverse. What is K if I know delta G naught? And so you just plug it in. Delta G naught equals negative RT ln K. And when you plug in all these numbers, and let's just say R times T is also equal to 2, right? 2 times ln K. K is equal to 4.8. Just to recap, I know it looks unfamiliar because I think we feel comfortable with this, right? When K is greater than 1, we have more product reactant. But guys, it's the same thing. If delta G naught is negative, I have more product reactant. But if delta G naught is positive, what that tells me is I have more reactant than product.